guys, it's IDW, and today we are going to be continuing along in our subtraction series. So, first of all, we are going to be building something that this time, unlike last time where we decremented two numbers, is going to be able to take two numbers and subtract them from each other. Well, we subtract one of them from the other, at least. If you remember from the previous video, the only difference between addition and subtraction is that they carry in different scenarios. So, if you remember correctly, what we did to make this incrementer right here into a decrementer was we inverted the input value because we needed to carry in the opposite state, or pass the value over to the next bit in the opposite state. But, since we need to do this by only affecting the inputs rather than a part of the logic within the adder, so that we can do addition and subtraction on the same circuit, we have to do this without, well, by changing one of the inputs. Now, if you will remember correctly, we can just do this by inverting one of the inputs into our first XOR gate. This will make it so that our first gate results in an XNOR gate. It will also make it so that we will carry when we want it to. The next part that we need to address is when we need to generate a carry signal. When we are subtracting, carrying means that we are subtracting from a bit that is ahead of this one that we are generating the subtraction from. So this means that we only want to carry if we are subtracting 1 from 0. In any other situation, we would give a positive result. For instance, 1 minus 0, that would be positive, positive 1. 1 minus 1, that would be positive, positive 0. Actually, 0 isn't positive or negative. Or 0 minus 0, which would once again be 0, and that wouldn't be negative. So, once again, the only time that we need to carry over is if we actually end up with a value that is negative for this bit. It might not be a negative result overall, but we're not going to be discussing negatives yet. Anyways, this means that the input that we need to invert for the adder is the second input of the AND gate and the half adder. Anyways, so if the only time we want this thing to be on is if we are only subtracting 0 minus 1, then what we have to do is we have to basically make it so that the AND gate that we already have within our adder will only turn on when just that input is on. And so that as we have to invert one input, then we know that for a fact that we're going to have to invert the one that isn't actually, sorry about that. We're going to have to invert the input that isn't actually on when we need it to be. This makes it so that both of the inputs for the AND gate are on. So that means that we're going to have the input that is not negative be the one that gets inverted. And we can't invert both of them because we have to get an XNOR gate. But anyways, the only difference between the inputs is basically that, as far as how it affects the adder. The one that you invert will be the positive input, and the one that you don't invert will be your negative one. So, yeah. So that basically sums up all the theory work that we need to do. Now let's get into actually making one of these. As you can see, I have already built the adder, and I've already inverted the positive input. However, there is a problem that this adder is already facing that was sort of suspected. As you can see, all of our outputs are off. Why is this, you might ask? And the answer is because right now we technically have an XNOR and an XOR gate in our adder, so it won't actually be working in the way that it works as an adder. Otherwise, this should work as a perfect subtractor, seeing as the way we've wired it up. So this is a bit difficult to solve, and the way that we're going to solve it for the moment is we're just going to invert the output, because if you remember, if you just invert the output, then it's the exact same thing as just inverting one of the inputs. It'll just make it into an XNOR. So, yeah. And if we invert these guys, then we should have ourselves an output of 0, 0, 0, 0, 0, as you can see. But the question becomes, can this thing actually subtract? And the answer is, of course, yes. You think all our theory work had gone down the trash. Anyways, so this is our positive input since it's the one that's inverted. So let's test this thing out. Let's do 12 minus 1. The answer should be 11. And as you can see, it's 11. Our subtractor is working. Anyways, so now we're going to move on to a couple of problems that we have with the current design. First of all, well, actually there's only one really big problem that's sort of staring us in the face right now. And that is what happens if, I'll just show you guys. Let's say we were to do ourselves 3 minus 5. This is 3 in binary, and that's a 5 in binary. Our result would be negative 2. Right. Yeah, this thing does not do negatives well. It does actually tell us that we have a negative because we get a carry out. That basically means, actually, that this value that we have in here is actually, well, basically, since it's basically carrying over infinitely, and it's basically saying that, how could I describe this? This is basically the adder telling us that we've subtracted something that resulted in a carry that was greater than what the adder could handle overall. And basically that means that it's negative. So the carry out actually does in fact tell you whether or not your output is negative. However, as you can see right here, we have a bit of a problem, and that is that our answer is negative. So in the next video, we're going to be solving this problem, and we're going to be altering this design that we have right here a little bit, just so that it makes it so that we can actually use negative numbers with it. So yeah, bye.